Pat, the owner at Sherpa, has asked two teams, Team Moab and Team Everest, to compete against each other on a bike challenge.
Designing, procuring, and assembling a bike with a budget of $800.
Retrofit it and modify it as needed to something that we thought would be a cool, rideable bike that Sherpas can use on a day-to-day basis.
We pretty much came up with the cargo bike design right away. It seemed now an easy fit to correlate with Mount Everest and Sherpas helping people.
Sherpas are carrying all your alpine gear up there. They have huge backpacks. They're going to base camp with you. And so we kind of wanted that base camp cargo holder and meeting the design with the prayer flags and a very bright alpine colors. John has great experience with chopping up bikes and making them to something new. So I think he kind of drove some of the confidence on making it a cargo bike.
I've built it, done a little bit of frame mods and everything on bikes, but I haven't built a cargo bike quite like this before. I did the welding at home, and I did the fitting of the tubes here at the office. It also involved, machining some surfaces on the fork, using some manual machining equipment here in the office, as well as just getting the geometry and everything right, figuring out all the angles.
The most difficult part of meeting the theme was interpreting the desert theme of Moab in not an incredibly literal sense. There was a temptation to go kind of far in terms of designing the ultimate survival bike for the desert, but ultimately we settled on a very futuristic sort of utilitarian design that incorporated the ideas of Moab wilderness without being quite so literal.
The role that we played was to set kind of a vision for what the bike frames would be, and we wanted to incorporate the elements from each of these projects, so Moab and Everest respectively, and bring in sort of the environment and the culture that surrounds both these locations into the aesthetics of the bike.
Mechanical engineering was already, they were kind of tackling all the parts on the bike. We could dictate kind of the general look and feel of what they were going to do, but ultimately that was their decision.
Some of the welding work that Michael did was really impressive as well. I was not expecting to see the front fork that we have now, but it is very cool and it does add a little bit of an aesthetic touch to the bike.
I'm a new welder, so I wanted to choose a task that gave me opportunity to stretch that a little bit. So the first thought was to do a front end with suspension, but then through kind of time constraints, as in busy in the summer, instead of doing just a more of a functional but aesthetic pleasing front end, and also that could house some of the components that the other teammates were working on.
I designed the brakes, so I learned a lot about different types of bike brakes. We had the brakes machined and CNC'd in our in-house machine shop. When I was doing research, I saw some cool companies machining brakes like Paul Components and took them as sort of a guide.
Learn how to use Teamcenter since none of my projects had incorporated that yet. I had to learn how to lattice parts for the carbon 3D printers. Luckily, we have Connor in 3DP, who is an expert at creating latticed bike saddles. So I got to learn from him how to 3D scan the hard plastic under portion of a bike saddle, take that surface, bring it into NX, and create whatever saddle model I like, and then split that up into different regions where I could specify a different density of the lattice in each region, and then also prepare it to be 3D printed by adding skins and textures so that it can be properly drained of all the resin.
I have some sewing experience, so I wanted to make a cargo bag with it, and especially because it could be easily integrated with the bike and removed easily, and kind of hoping to flush make the ID design continue to more than just the frame.
Some of my teammates came up with some pretty fantastical concepts like Jim's lock.
The component I worked on for the project was a bicycle lock that was operable by the RFID key fobs that were all issued as members of Sherpa. And this is an example of the key fob here. It's a fairly standard key fob that we use to open the doors. The first step was to explore how the fob and the reader work together. Whenever the key fob is brought close to the reader, it sends a distinctive pattern that's easily seen on an oscilloscope. It was straightforward to design a digital circuit to look for that pattern and a circuit board to actuate a solenoid that would custom fit within the enclosure. The internal locking mechanism was designed to be rugged and secure and was machined from aluminum and stainless steel for strength. The whole assembly was assembled and tested, then securely attached to the bike frame.
So my role on the team was really to make the bill of materials as clean as we could possibly make it, which of course we didn't have everything put in CAD, so we were kind of making essentially blank parts as placeholders to fill in some of the things that we didn't quite have, but that's kind of normal in a product design world until you hit that first phase gate when you're like, okay, well, this is where we want to move forward, and then we're going to go ahead and go back and revisit the bill of materials, make sure it is what we want it to be. It's not something we're going to send out to another company to have them build it, but we do want to have an accurate bill of materials so we understand the cost of the bike and then the amount of work it took to get that whole thing put together.
Incorporating the power bank into the bike created a power source for everybody to use. I added in wireless charging for a phone, a weatherproof enclosure for the phone so that you could always have it out, always displayed, always facing you, be able to interface with it hands-free, but also always be topping off the charge of the device while you're riding. Simply sticking it in, it charges just being in position.
Not only was the taillight powered so it could be an LED flashing light, but it was also built using a reflector so it could be used even when you lose power or you need to recharge. We made an optional storage box that could be mounted to that rack, and that was the challenging part. Ultimately, we ended up with a nice compact solution, insulated, and it's the perfect size to pack a lunch or pack a six-pack and head out on the bike.
After some crucial judging and scoring, Team Everest came up with a score of 271 points, and Team Moab came up with 261. So Team Everest, congratulations, you are the first Constructors Cup victory.
Feeling good. I was really excited to see both bikes, in real life. I didn't know it could have gone either way. So it seemed like from the points that it was really close. But yeah, we're happy to take the W and see you next year, hopefully. Oh man, it was a tough fight. But
seriously though, great event. So proud of both teams. To Team Everest for pulling up the championship on Moab. So what a part of all the team members coming together, working together, building that beautiful bike over there.
Both bikes, when we unveiled them, were way better than I thought we were going to be able to do on P-Mods. We actually incorporated things that people wanted into the design. We're able to do it pretty close to budget.
I was surprised what the other team came up with, and I was kind of expecting them to weigh in a little bit, honestly, after we saw presentations.
Seeing everything come together in one really kind of beautiful physical product. That's always sort of the end goal with our projects, and being able to do that with engineers across other teams here was a lot of fun, and it was really nice seeing how cool our bike was and seeing the other team's bike, which was fantastic.